Okay, selamat sejahtera. Alright, very good evening. So today we are going to do another section of electromagnet. It's going to be practical essay question. Alright, electromagnet, we're going to do two. Alright, one is dynamo, the other one is motor. Alright, these two are in the chapter of electromagnet. We see what the question is all about. Alright, kita tengok ada dua soalan kita buat. Satu berkenaan dengan dynamo, satu berkenaan dengan motor. Jadi macam mana kita tahu yang mana dynamo dan yang mana motor? Senang sahaja. Berdasar kepada apa yang diberi. Okay. Alright, kita tengok yang pertama. Alright. Okay. Diagram 5.1 and 2 show two different dynamo. They already tell you. So this is confirmed a dynamo connected to the same type of bicycle lamp, but both tires are rotating with same speed. So laju sama. Alright. Okay, laju sama. So now we are going to look at the number of turns. Okay, effect. Why? Because we know this one is less number of turns. This one is more number of turns. So understood. Alright, the manipulator will be the number of turns in the coil or solenoid. Alright, so understood. One is dimmer, the other one is brighter. So understood is going to be the current induced. So induced current. Okay, all right. So understood, the more number of turns, when you write the hypothesis, the greater the number of turns in a coil or solenoid, the higher the induced current. Okay, look at the aim to investigate. You're going to use back the same tool. One is manipulated, one is responding. All right, to investigate the relationship between the number of turns, all right, is manipulated, right, number of turns in the coil and the induced current. Jadi dalam bahasa sama, mengkaji hubungan di antara bilangan lilitan dalam gegelung solenoid dan juga arus yang diarahkan. Is it okay? And understood. Okay, the constant variable will be the height of the magnet release. All right. So I'm going to change the question now. All right, to another type of questions. All right. Let's say I have the same number of turns. Okay, this and this the same. Let's say kedua-dua. All right, both of them I give number of turns, okay, to be the same. All right, let's say I'm going to have 100 turns. All right, 100 turns. Okay, so understood. All right, okay, this one, diagram number 2, going to put it in green color. All right, I'm going to pedal the bicycle fast. So understood. All right, when I pedal the bicycle fast, it will produce a lot of current. So it's going to be brighter. Okay, it's going to be brighter. So I changed the question a little bit. Boleh, huh? And on the left side, I'm going to put it in blue color. This one, I'm going to pedal the bicycle slower. Clear? Slow. So understood, because I pedal the bicycle slow, it becomes dimmer. All right, look at the lights. All right, look at the lights. All right, we know that the lights is going to be dimmer. Okay, lebih malap lampu dia. Clear, huh? All right, senang sahaja. So kita dapati bahawa kita nak tulis benda yang sama. Alright, so what is a manipulator? What's a responding? Okay, so understood. One is fast, one is slow. Alright, okay, but when you do the experiment, you cannot use the word fast and slow because it's not measurable. Jadi apa yang kita akan buat? Nah, kita beralih kepada jawapan. Ini jawapan yang diberi oleh murid cikgu. Alright, okay, we're going to look at. All right, zoom in to look at the diagram first so that you are aware how we actually make use of the diagram. Instead of using the speed, we use the height of the bicycle. We use the height of the magnet. All right, we use the height of the magnet. Kita gunakan ketinggian magnet untuk dijatuhkan. All right, jadi memang difahami bahawa bila magnet diletak pada kedudukan lebih rendah dan dibiarkan jatuh, maka dia akan bergerak dengan lebih perlahan. But if you were to pull the magnet, okay, place the magnet higher and let it drop, then understood it will be moving with a higher speed, just like you pedal the bicycle fast. All right, very simple. Let's take a look at the manipulator. All right, okay, manipulator is over here. So it is saying that the height between the solenoid and the magnet, can you see or not? All right, the height between the solenoid and the magnet. These actually represent the speed, which is the correct thing for you to write. Okay, benda ini kita kena tulis kerana pemboleh ubah manipulasi, kita mesti pastikan dia dapat disukat. Jadi ketinggian magnet Alright, dari gegelung solenoid. Itu dapat disukat. Okay, jadi responding variable understood. Right, responding variable will be the magnitude of the induced current ataupun arus diarahkan. And the constant variable become number of turns. Clear? Alright, so apparatus very simple, solenoid, we have soft iron core, we have magnet, bar magnet, we have ammeter, we have, alright, okay, we have ruler. Clear? Alright, to measure the, how should I say, the height. Let's take a look at the aim and the inference. Alright, okay, look at the aim, huh? Alright, look at the aim. Alright, to investigate the relationship. Alright, very simple. To investigate the relationship, we use back the same word manipulated, the height of the, right, the height between the solenoid and the magnet, all right, and the magnitude of the induced current. Clear? We use back the manipulated variable and we use back responding variable. Alright, dalam bahasa sama juga mengkaji perhubungan di antara, alright, ketinggian magnet dari solenoid dan juga arus arohan yang dihasilkan. Alright, hypothesis. Let's take a good look. Alright, the higher, right, when the height of the magnet on the solenoid, alright, when the height between the solenoid and the magnet increases, the magnitude of the current induced increases. Senang saja. Alright, dalam bahasa semakin tinggi jarak dari solenoid dan magnet bar, alright, semakin tinggi arus akan diarahkan. Alright, so in English we can put it like this using the word the higher the height between the magnet and the solenoid, the higher the magnitude of the induced current. Alright, then look at the inference. Okay, look at the inference. The brightness of the light depends on the speed of the bicycle. Okay, wheels that turn. Clear? Or you don't use the word depends on, you will use the word affect. I prefer you to use the word affect. So, mempengaruhi. If you use the word affect, then you're going to put the speed of the bicycle in front. All right? The speed of the bicycle wheels that turn affect the brightness of the light. Okay? Or affects the brightness of the bulb. Is it okay? And then if it's okay, we are going to move downward. We're going to look at, all right, the procedure. All right, we have the apparatus. All right, we're going to look at the procedure. So procedure very simple. Set up experiment. That one not necessary for you to write. All right. Then you look at the second one. Okay. Wind using wire. Okay. Wind the number of turns of the coil of the solenoid. Okay, at 50 turns. Clear? All right. And then understood. Okay. Let's move downward. Let's move down. All right. Okay, I think what is written there, all right. Oh, okay. What is written there is one sentence which is missing. All right, I think it's going to be the, here. All right, it's actually sambung dari sini. Sorry, sambung dari sini. All right, place the magnet at a height of 5 cm. Only 5, right? We can start with 5. Why we start with 5? Why we start with 5? Because the first value is a 5 here. Betul? All right, the first value is a 5 here, then we start with 5. All right, place the magnet, all right, at a height of 5 cm, all right, above the solenoid. Okay, all right, and release the magnet. You can continue. Okay, actually you can continue, and the magnet is released. Okay, letakkan magnet pada ketinggian 5 cm dari gegelung solenoid dan dilepaskan. All right, measure and record the magnitude of the induced current. Arus yang diarahkan, okay, direkodkan. Magnitude arus yang diarahkan, direkod. Okay, that is your responding. So understood, this and this will be your manipulated variable. You talk about the height. Okay, manipulated variable. Okay, you talk about the height. All right, of the magnet from the solenoid. Okay, and understood this and this, you are going to talk about the what? All right, the responding variable. All right, measure the current induced. Clear? And then the next sentence understood. This will be your repetition. All right, repetition. Okay, you will say that magnet will be released from a height, okay, which is increased to, right, all the different value. Okay, you put all the different value. Okay, 10 cm, 15 cm, 20 cm, 25 cm, 30 cm. It must match all the value here. You see or not? All right, 10 cm, 15, 20, 25, and 30 cm. Okay, so it must match all the value there. Otherwise, marks will be deducted. Clear? Jadi dalam bahasa kita kata ketinggian magnet dari solenoid tingkatkan ke 10 cm, alright, 20, 10 cm, 15 cm, 20 cm, 25 dan 30. Alright. Okay, iaitu eksperimen itu diulangi, then you akan mendapat lepas tabulasi, table of tabulation, you have the graph. Okay, so you mentioned a graph of current against the height between the solenoid and the magnet, okay, is plotted. Right, since you haven't done experiment, leave the graph empty, no need to show. All right, just make sure your manipulated will be, remember, manipulated, the height between the magnet and the solenoid. Responding variable will be the magnitude, okay, responding variable, magnitude, okay, of the induced current. Okay, that's dynamo, one. So remember, whenever you are given question on dynamo, all right, your diagram is going to be always like this. All right, sorry. Okay, hang on, I'm going to make it smaller. All right, your diagram is always the same, the one that you have seen just now. This one. Ingat, all right, adik-adik. All right, this question is very popular. Every time you are given dynamo, this is your drawing. You are going to use magnet to fall down, right, into a coil or solenoid. Faham tak? Alright, kita banding dengan motor. Alright, kita banding dengan motor. We have a question based on motor. Let's take a good look. This is actually motor. Alright, okay. Let me see. Alright, diagram 7.1 and 2 show a mixer. Okay. Alright, 7.1 show, alright, the dial is set at a minimum current and beaters are spinning. But 7.2, alright, it is set at maximum. Do you notice the maximum here? You show here maximum. This one you show here close to minimum. They told you show the minimum, then it spins slow. And when you change the dial to show, alright, maximum, then it spins fast. So macam kipas lah. Clear? Macam kipas. Alright, fast. Betul tidak? Alright, and then you need to talk about it. Alright. Okay, let's take a look. Okay. Alright, understood. Manipulated will be the current. All right, how fast it turns, understood, depends on current, betul? All right, it depends on current. Okay, and the responding is always distant because it's a motor. Motor concept use distance of the copper rod that move. Clear? All right, and the responding, the constant variable, you can say the strength of the magnetic field pun boleh. All right, kekuatan medan magnet. All right. So understood, the rest like the aim you know lah. You just write to investigate relationship between, right, between manipulated and responding. All right. Okay. Then the higher hypothesis, the higher the manipulated variable. All right. Comma, the higher the responding variable. Okay. Semakin tinggi arus digunakan, semakin tinggi. All right. Okay. Jarak di mana rod couple bergerak. Clear? Or you may use the word, okay? The higher the current, the higher the magnetic force. All right, produced. Clear? All right. So here is written that, okay, the beater spin, all right, depends on the current. Or you terbalik, okay, the current affect. Use the word affect, the one I mentioned just now. Affect the speed, okay, of the beaters. Okay? All right. Okay, current you're going to put in front. All right, current you're going to put in front. All right, okay, and then the speed, all right, of the spinning of the what you put at the back. Okay, so we're going to move at another example. It's almost similar because this is a fan. All right, it's almost similar. It's also using motor. Clear? Understood? Even if you don't read, the logic will tell you. All right, this one we are adjust it. Okay. So that the current is low current. Okay, low current, then you notice that it rotates slow. Okay, slow. Okay, and the other one understood, high current. High current, you notice that, all right, it spins faster. Nampak? All right, it spins fast. So it's like tadi lah. All right, so what causes the fan? Apa yang menyebabkan kipas berputar? Okay, dengan laju, dengan perlahan dan dengan laju. Understood? Arus, betul tidak? So your manipulator will be the current. Clear? Alright, and the responding will be the distance of the rod copper that move. So we're going to look at the answer given by my student. Alright, okay, which is here. Always remember, this is diagram you use for motor. Every time they ask you motor, you are going to use this diagram. Remember that, huh? Okay. Every time they give you a motor, you are going to use this concept. All right. This is our center, Sri Sajana, all right, tuition center. All right. If you are interested to learn, then let us know. Clear? Okay. Let's take a good look, huh? Let's take a good look. So I'm sure you have seen this diagram. All right. We have a C-shaped, okay, iron York. All right. This one, C-shaped iron York. You notice that? Then we have the magnet, one at the bottom, one at the top. Clear? All right. Here is a label here. Okay. You see that label magnet here. There's another magnet at the top. Clear? All right, huh? And then we have, what should I say? All right. We are going to have, how should I say? All right. There's a little bit of problem here because you need to connect to, okay, a little bit of mistake here. It's not emitter. All right. Okay, emitter. Then here you have the power supply. You don't want to use power supply, you can use dry cell current. This is just to measure the current. Clear? All right, we measure the current. Of course, you want to measure current, the best thing is you're going to have a rheostat here. You need to connect a rheostat because you're going to use the rheostat, all right, to adjust the current. Okay, you draw the rheostat. Clear? All right, very simple. Okay, let's take a look at the manipulated variable. All right, this is manipulated variable. The current, the flow through the circuit. Okay, all right. So you understood. You adjust using rheostat. Okay. Then understood. Responding variable will be what is written there. The displacement of the bare copper wire. Then constant variable. What did I mention just now? Strength. Okay. Saya ulangi ya. Di pembalik ubah dimanipulasi. Arus yang mengalir melalui litar. Alright, bergerak balas. Alright, displacement ataupun jarak sasaran yang dilalui oleh wire kuprum. Alright, constant variable, kekuatan medan magnet. So we look at the aim to investigate relationship between manipulated variable, current that flow in the circuit, and the responding displacement of the bare copper wire. Clear? Look at the hypothesis. The higher the manipulated variable, current that flow, the higher the right displacement. This student changed to the word force. That's why it's wrong. You notice the student write the word force there. I erase so that you can see. That's why I put a cross there. You nampak? I put a cross there. Then you should use back the same word, displacement. All right. You don't change the word tiba-tiba force lah, tiba-tiba daya lah, tiba-tiba momentum lah, tiba-tiba kelajuan lah, tiba-tiba pecutan lah, tak boleh. You have to use back the same word. Displacement. You already mentioned displacement. Use back displacement. Boleh? I repeat. So the correct sentence will be, the higher the current that flow in the circuit, the bigger, okay, the displacement. All right, the bigger the what? Displacement. Okay, the bigger the displacement. Use back this word. All right, the bigger the displacement, all right, of the bare copper wire. All right, so look at the inference. The current that flow, all right, the current that flow through the motor affect, okay, the force of the beater, okay, the force of the beater that spin, okay. So the apparatus, I am pretty sure you have no problem. All right, you have the power supply, then you have this magnet, C-shaped iron York, right? Bare copper wire, connecting wire, ruler, and emitter. Okay, we're going to look at, all right, the continuous answer. Make sure you know we are talking about the procedure. All right, let's take a look at that. Okay, sorry. Where is it? Okay, maybe okay, let's take a look at the procedure, huh? Okay, I'm going to make it slightly bigger, all right, so that you can see. All right, the emitter supply is adjusted. You see, this student didn't know what to write to adjust. All right, it's adjusted by using a rheostat. Okay, you continue by using a rheostat. Okay, okay, arus dalam litar, alright, diselaraskan dengan menggunakan rheostat. Alright, supaya arus yang mengalir melalui litar, okay, mencapai 0.2 ampere. So we start with 0.2 first. So understood, manipulator will be the current that flow in the circuit. Clear? Alright, after that, this is your first sentence. Understood? First sentence mesti bercakap tentang manipulated variable. The second sentence, you're going to talk about responding variable. Alright, the displacement of the bare copper rod is measured by ruler. Okay, done. Alright, and it's recorded. Okay, recorded. And then the third sentence will be the repetition. Alright, the above steps are repeated by increasing the current to, you see, 0.4, 0.6, 0.8, and 1.0. It must match the value here. Alright, okay, and this is the second column, understood lah? Responding variable, the displacement of the bare copper wire. Boleh? And the last one, understood, is going to be the graph. All right, as usual, you're going to leave it empty. All right, okay, it'll be better for you to write a simple statement, a graph of displacement. Whenever you mention graph, you need to mention y-axis, all right, which is your responding variable. Okay, boleh ubah bergerak balas dulu. All right, a graph of displacement of the bare copper wire against current. Then against current, this will be your, all right, manipulated variable ataupun boleh ubah dimanipulasi. Clear? And leave your graph empty. That's all. All right. So remember, all right, before I go off, I need to remind you whenever question is talking about motor, remember, jangan terlupa. Kalau soalan berkenaan dengan motor, mesti gambar raja ini. Alright, mesti gambar raja ini, iaitu gambar raja memerlukan, alright, bentuk C, iron yoke, okay, C-shaped iron yoke with magnet, alright, and then using the bare copper wire, it will move. And we measure the displacement of the bare copper wire. Kita menyukat sasaran, okay, dawai kuprum yang digunakan itu. Clear? This one, remember, this is for motor. Whenever motor, remember, all right, you have a C shape, okay, iron yoke with magnet. Clear? All right, C shape. Okay, remember C shape. But when it is going to be for dynamo, dynamo, you must use magnet. All right, because you're going to produce current. This is dynamo. All right, magnet falling down into a solenoid. Okay, or okay, we use bahasa magnet dibiarkan jatuh ke dalam satu gegelung solenoid. Clear? All right. So remember, this is going to be dynamo. All right, dynamo, you must remember you need to have magnet. Boleh ha? So with this, don't get confused. Hanya dua saja. Satu dynamo, alright, satu dynamo, satu okay, magnet. Boleh? Satu dynamo, satu magnet. Itu saja. Asalkan adik-adik tahu bezakan kedua-dua ini, and then you are fine. Alright. So with that, we will come to the end of our session today. Till we meet again. Alright, see you then.